magliliwanag ang ating kinabukasan. Dance Radio, silid-aralan sa radyo, hatid namin makabagong paraan ng pagtuturo. Kahit saan at kahit kailan, hindi ka iiwanan, hatid namin bagong kaalaman. Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kaalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big. Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Hello po! Naririnig po ba ako?
Oo, Ma'am Rio.
Yes, Ma'am Rio, naririnig kita.
Ayan! Maraming salamat po. Ayan, so good afternoon po sa ating lahat. And we're back. Ayan, muli po kaming nagbabalik ang inyong mga science teachers. At syempre, ang ating programa na pinamagatang It's Scientific Time! Ayan, so it is another school year, Sir Hector and Ma'am Linda, no? So, panibagong taon. So, sana, our dear students, sa buong taong panuruang ito ay muli namin kayong makasama mula simula hanggang sa dulo. Ayan. So, para pag-aralan pa ang mga aralin tungkol sa agham. Ayan. So, ang programang ito or sa tanghaling ito ay para sa inyo, our dear grade 8 learners. So, muli, isang mapagpalang hapon sa ating kaguruan, pinapangunahan ng ating matyagang ama ng institusyong ito, Dr. Rodrigo V. Pascua, the Chief Education Supervisor and our Officer in Charge, sa ating masipag din na Assistant Principal, Ma'am Ruby Guillermo, at sa mga mababait na head teachers and teachers from different learning area. Yan. Sir Hector?
Yes, ma'am. Good afternoon din sa ating lahat. So, first airing ng Scientific Time ngayon. First na topic. Pero hindi tayo mag-uumpisa sa pinaka-first na topic kasi nasa week 2 na tayo. So, ang gagawin na lang natin ay magkakaroon na lang tayo ng recap or review para doon sa pang-first week ng mga modules. So meron tayo dyan, si Ma'am Linda, kasama rin si Ma'am Rio, na kung saan bibigyan tayo ng brief review para doon sa mga naunang lessons. Ma'am Lynn?
Hello, good afternoon, Ma'am Rio. Good afternoon, Sir Hector. Good afternoon sa lahat ng mga nanonood at nakikinig, especially the grade 8 learners. Okay. So, Sir Hector, before na mag-review tayo, mag-air pa muna tayo, di ba?
Oh, yes, ma'am.
Okay, so Sir Hector, what to expect for today's lesson? Ano ba ang aabangan ng ating mga learners ngayon? Ano ba yung mga matututunan nila this afternoon?
Oh, yan. Yan yung pinaka-meat ng ating lesson ngayon. So at the end of the lesson, the learners are expected to identify the factors affecting potential energy and kinetic energy. So hindi na natin ito patatagalin. Atin nang pakinggan ang ating RBI para sa hapong ito.
It's Science Terrific!
Dance Radio, siniparalan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Facts and information. Today's learning for new normal. With capable teachers whose heart and souls are defined. Deliver knowledge inside your home through radio. This is DWDR-FM 106.3 Dance Radio, a community FM radio station of Doña Aurora National High School, Santa Rita, Aurora, Isabela. This is DWDR-FM 106.3 Dance Radio, fully dedicated to serve the public in tribute to education. With the use of radio-based instructions, we are pleased to deliver the utmost aim of education through distance learning approach. With subjects like English, Science, Math, Filipino, Araling Palipunan, TLE, Mate, and ESP. This is DWDR-FM 106.3 Dance Radio is now ready to serve you right inside your home. This is DWDR-FM 106.3 Dance Radio, your school on the air. Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science. And now, here is your host for the day. Rio.
Good day, everyone. I am Teacher Yufei, your radio teacher in science. Before we start, make sure that you are in a comfortable place and far from noise or any disturbance so you can hear me loud and clear. At this point, don't forget your module in Science Week 2. Before we start, be sure you have your pen, paper, and notebook with you. So please open your module and let us have a quick walkthrough. Make sure that the title of your module is Potential Energy and Kinetic Energy. To be guided in using this module, you should do the following. First, read and follow the directions or instructions in the activities carefully. Second, take time in reading the lessons. Lastly, answer honestly all the activities. Today's lesson is about potential energy and kinetic energy. After going through this module, you are expected to identify and explain the factors that affect potential and kinetic energy. Welcome to our second School on the Air lesson in Science 8. You have already a prior knowledge about potential and kinetic energy when you were in grade 7. In our lesson today, we will dig deeper on how this topic can be useful in our daily life. To start with, let us recall the meaning of energy. What is energy? Energy. Energy is the ability or capacity to do work. Energy. Capacity to do work. Its unit is the same as the unit of work, expressed in joule in the International System of Units. 1 joule is the amount of energy needed to accomplish 1 joule of work. A larger unit of energy called kilojoule is sometimes used. 1 kilojoule is equal to 1,000 joule. In the previous lesson, you were asked if the man lifting the box is doing work on it. Please refer to your module on page 7, figure 1. You can see a man lifting a box. Which or who is doing work? Is it the table, the box, or the man? Yes, you are correct. The man is doing work on the box.
Winner!
Specifically, the force he applied while lifting is doing work on the box. What is the direction of the force exerted by the man on the box? How about the direction of the motion of the box? Yes, both are directed upward when the force and the motion are in the same direction. There is work done on the system. Wow! Work, as discussed earlier, is a way to transmit energy. Hence, work is a way to transmit energy. Wow! Hence, when the man exerted force in lifting the box, he loses energy. Work is done on the box and the box gains energy. You have learned that force of gravity is the force exerted by the Earth on all things within its gravitational field. It is always directed downward or towards the center of the Earth. Consequently, when an object is raised from the Earth, The force exerted in lifting the object is equal to its weight, where weight is equal to mass multiplied by acceleration due to gravity, or mathematically, W is equal to mg. The work done in lifting the object is work is equal to force multiplied by displacement. Mathematically, W is equal to Fd. W is equal to Fd, where the displacement is the height the object is raised. Thus, the work done in lifting the object against the gravitational force is given by the work performed in lifting an object is equal to the potential energy the object gains. An object absorbs energy when lifted from the ground, and when allowed to fall, it loses energy. The energy that the body gains or loses with respect to its position is called potential energy, and is given by potential energy is equal to mass multiplied by acceleration due to gravity multiplied to its height, or mathematically, PE is equal to mgh. PE is equal to mgh,
Yes.
where PE is the potential energy in joules. M is the object's mass in kilograms. G is the acceleration due to gravity, which is 9.8 meter per second squared. And H is the height of the object from the reference point in meters. Before we proceed to the next discussion, let's have a short break first.
Force and motion facts. Motion makes the world go round. Motion makes the moon go round too. In fact, motion makes lots of things go. When we think of motion, we often think of cars, bicycles, kids running, basketball bouncing, and airplanes flying. But motion is so much more. Motion is important to our lives and impacts so many things that we do. Motion is the changing of position or location. But motion requires a force to cause that change. Let's learn about force and motion and the effects of these physical laws in our world. Force and motion facts.
Science Trivia.
Science trivia.
Science Trivia.
If you have any question or concern about the lesson for this hour, you may text your subject teacher using the numbers located at your learning package. You may also send them your questions through their messenger and their email found in your learning packages as well.
It's science time.
You are listening to Teacher Rio.
I am back. Hope you are still with me. So after discussing potential energy, let's talk about the other type of energy, the kinetic energy. What is common in the following situations? A running athlete on the track, a flowing water on the ground, a falling coconut from its tree, a rolling rock on the seashore, and a soaring airplane into the air. What is common in the following situations? That's right. They are all moving and are acted upon by forces. Any object that moves possesses energy and can do work. Well, an object that moves quicker can do more work than an identical object that moves slowly. How much energy does a moving object possess? We can say that the kinetic energy of an object moving at a certain speed is equal to the work done to make it acquire that speed. Hence, the energy of a moving object is called energy of motion or kinetic energy. Kinetic energy. Energy of a moving object. The word kinetic comes from the Greek word kinetikos, which means moving.
Kineticos, moving.
Kinetic energy measures the amount of work the object can do because of its motion. This can be computed using the formula Ke is equal to 1/2 mv squared, where Ke is the kinetic energy in joule, m is the object's mass in kilogram, and v is the object's speed in meter per second. From the formula, the kinetic energy of an object depends on its mass and speed. What will happen to the kinetic energy of an object if its mass is doubled but the speed remains the same? You are correct. The kinetic energy of an object is also doubled. How about if the speed is doubled, but the mass remains the same? Very good! The kinetic energy of an object increases 4 times. Wow! This means that the greater the mass, the greater the kinetic energy. And the faster the speed, the higher the kinetic energy as well. Wow! We'll be right back for more activities after this short message.
Buboy, pumasok ka na rito at kakain na tayo. Itigil mo na yung paglalaro.
Sayang, mag-home base na ako. Si Nani naman, wrong timing.
Nako, kapag tayo po ay uubo o babahing, mangyaring takpan ng ating ilong o bibig ng siko o tissue upang maiwasan ang pagkalat ng virus. Sinigang para sa tanghalian.
Amoy pa lang, panalo.
Wait! Ugaliin po natin ang puspusang paglilinis ng kamay gamit ang sabon, hand sanitizer at alcohol. Patuloy pa rin ang banta ng COVID-19 kaya tayo ay maging responsableng mamamayan. Sa kaligtasan ng bayan, disiplina ang kailangan. Stay home, save life.
Isang paalala mula sa himpilang ito.
It's Science Time!
You are listening to Teacher Rio.
Okay! Are you ready to level up our discussion through a series of activities?
Yes.
Let us perform an activity on kinetic energy on page 9 of your module. After performing this activity, you should be able to investigate the changing the mass or speed affects the kinetic energy of the object. The situations and explanations are introduced to guide and help you answer the questions that follow. For situation A, 2 vehicles of different mass, one is 10,000 kilograms and the second is 5,000 kilograms. They move at the same speed, which is 10 meters per second. The kinetic energy of a 10,000 kilogram vehicle is twice as much as the kinetic energy of a 5,000 kilogram vehicle when both are traveling at the same speed. Why is this so? The 10,000 kilogram vehicle has twice as the mass of the 5,000 kilogram car. Since they are traveling at the same speed, the kinetic energy is doubled. Therefore, kinetic energy is directly proportional to the mass of the object when speed is held constant. That means, the more massive a moving object is, the greater is the kinetic energy it carries, and vice versa. Situation B. Two vehicles of the same mass, 1,500 kilogram, moving at different speed. One is 10 meters per second, and the second one is 5 meters per second. The kinetic energy of a car traveling at 10 meters per second is 4 times the kinetic energy of a car traveling at 5 meters per second. Why is this so? Okay, a car traveling at 10 meters per second has twice as the speed of the other car, since the mass is the same for both vehicles. The kinetic energy is increased 4 times. The kinetic energy is directly proportional to the speed. Therefore, the greater its kinetic energy. This time, complete Table 1. Effects of mass and speed to kinetic energy. Read with me the procedures. Are you ready?
Yes.
Complete the table. Refer to the situations and explanations to guide and help you determine what happens to kinetic energy of an object when either mass or speed is changed. Use directly the formula of kinetic energy. Ke is equal to 1/2 mv squared. Use directly the formula of kinetic energy. Ke is equal to 1/2 mv squared. Number 1 is done for you as your guide. The remaining items will serve as your exercise. You can answer that in your most convenient time after our episode. Before we go on to the next activity about potential energy, let's have a short infomercial break.
Mare, nabalitaan mo na ba na nag-o-offer ng radio-based instruction or RBI ang Doña Aurora National High School?
Ganun ba, Mare?
Ito yung bagong paraan ng pagtuturo gamit ang radio.
Kung ganon, di na ako mangangamba. Doon na ako sa Doña.
Ngayong laganap ang pandemya sa bansa, marami ang nangangamba. Edukasyon ng anak, inaalala. Huwag nang mangamba sapagkat dito sa Doña, sagot kita. Gamit ang radyo sa pagtuturo, ikaw ay di na matutuliro. Radio-based instruction ang kasangga mo sa edukasyon ng anak mo. Sapagkat sa Doña, bawat bata mahalaga.
If you have any question or concern about the lesson for this hour, you may text your subject teacher using the numbers located at your learning package. You may also send them your questions through their messenger and their email found in your learning packages as well.
It's Science Time!
You are listening to Teacher Rio.
I'm back! Hope you are still with me. Can you follow, my dear learners? Did you understand the concept about kinetic energy? I hope so. Now, let's proceed to the next activity about potential energy on page 11 on your module. After performing this activity, you should be able to investigate that increasing or reducing the mass or height affects the potential energy of the object. The situations and explanations are introduced to guide and help you answer the questions that follow. First, situation A. Two objects of different mass. First object is 10 kilograms. Second object is 20 kilograms, which are situated at the same height. The potential energy of 20 kilogram box is twice as much as the potential energy of 10 kilogram box when both boxes are of the same height from the ground. Why is this so? The 20 kilogram box has twice as much the mass of the 10 kilogram box. Since they are of the same height from the ground, the potential energy is doubled. The greater the mass of an object placed in a certain vertical position on height, the greater is the potential energy it possesses and vice versa. This time, let's have situation B. Two objects of the same mass are situated at different height. First object's height is 5 meters, while the second object's height is 10 meters. The potential energy of the box that 10 meters from the ground is twice as much the potential energy of the box that is 5 meters from the ground when both boxes are of the same mass. Why is this so? That is because the box is 10 meters from the ground, has twice as much height of the other box. Since mass is the same for both boxes, the potential energy is doubled. The higher the position or the height where the object is located, the greater is the potential energy and vice versa. How are you, my dear learners? Did you understand the concept about potential energy? This time, let's take a simple exercise on potential energy on page 12 on your module. Complete the table below. Refer to the situations and explanations to guide and help you determine what happens to potential energy of an object when either mass or height is changed given a constant value of acceleration due to gravity, which is 9.8 meter per second squared. Use directly the formula of potential energy. PE is equal to mgh. Number 1 is done for you as your guide or example. The remaining items will serve as your exercise, and you can answer that in your most convenient time after our episode. To deepen your understanding on the concepts about potential and kinetic energy, answer the given activity. Here is the directions. Identify whether the objects in the given situations possess potential energy or kinetic energy. Write your answers on a separate sheet of paper and do not forget to include that in your folder. Then give it back to the knowledge bearers. Are you ready?
Yes.
Let's start. Number 1. Bird flying. Number 2. Log in a fireplace. Number 3. Watermelon on a desk. Number 4. Car traveling on the highway. Number 5. Car sitting in a driveway. Number 6. Bunch of a coconut stick on a table. Number 7. Ball bouncing on the floor. Number 8. Child jumping on his bed. Number 9. Child sleeping on the crib. Number 10. Marble rolling down the ramp. Did you get it? Write your answers on a separate sheet of paper and do not forget to include that in your folder.
Yes.
Alright, now we're done with the lesson. As your assignment, answer the questions on the assessment part of your module. Please follow the directions. That's all for today. Again, I am Teacher Rio Faye Magaway saying, the energy of the mind is the essence of life. Thank you very much.
Thank you, Teacher Rio. Alright, I'm back. I'm your host, Teacher Dennis. How was your learning today, our dear learners? I hope your learnings today can make a significant difference in your point of view about the potential and kinetic energy.
Yes, sir.
Just a reminder, if you have any concern about our topic, send them to this number, 0977-158-2802, or email us at 19hectorderosario@gmail.com. I would like to acknowledge the teachers behind this School on the Air lesson. Teacher Rio Faye Magaway, your radio teacher on the air. The scriptwriters, Teacher Arlinda S. Ramos, and Sir Hector M. Del Rosario. And Teacher Riza N. Marsan, our technical specialist. I'm Teacher Dennis, your host, saying thank you very much. Stay tuned for the next subject.
Dance Radio, siniparalan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Hello! Ayan. So, nagbabay po inyong mga boss sa Sign 8. So, inyo pong napag-aralan, our dear learners. Okay, ang topic natin all about potential energy and kinetic energy. So, but before we dig further on our topic, let us have first a simple recall sa ating lessons, okay? Which is all about forces and laws of motion. Diba, Sir Hector?
Oh, ma'am. So, kagaya nga ng nabanggit ko kanina, bago tayo dumiretso sa ating intended na lesson ngayon, magre-review muna tayo saglit kasi ito nga yung kauna-unahan natin na airing ngayon dito sa Science 8. So, Sir Jacel, pakikuan nga yung screen ko. Ayan. Oh, Ma'am Linda.
Yes, Sir Hector. So, last week, during the first week, so naibigay na natin sa ating mga learners ang kanilang mga modules. So, ang module 1 is all about forces. Okay? So, here in forces, so there are, so what is force? Okay. So, ayan. So, when we say force, that is a push or pull acting upon an object as a result of its interaction with another object. So always remember that forces do not always cause motion. Now, what can forces do? So forces can produce changes in motion. Okay? The force can make the ball or any object move. It can move faster, or it can make it stop or change its direction of the motion. Okay, so there are two types of force. First, we have the contact forces. So when we say contact forces, the objects touch or contact with each other. And there are examples of contact forces. What are these? Okay, one is applied force. So when we say applied force, that is a force given to a person or object by another person or object. Number 2 example is friction. So when we say friction, that is the force acting against or opposite an object in contact with, which makes the movement of the object slow down. So friction always opposes the motion of an object. Okay, another number 3, we have normal force. So when we say normal force, is the force that acts perpendicular to the surface of the object in contact with. And number 4 is tension. Tension, that is the force applied to string, rope, chains, or cable. And its symbol is capital letter T. Okay. Then we have also the second type is non-contact forces. So when we say non-contact forces, objects do not touch or contact with each other. And these forces act over a zone or area called field. Examples under non-contact forces, one is gravitational. The force of attraction between two objects. Example is the Earth and Moon. Number 2, we have the magnetic force. Here, the forces exerted in the field of attraction or repulsion, as in the case of magnets and other magnetic materials. Okay, so when do we say that a force is balanced or unbalanced? Okay, so when we say balanced forces, here, the forces that are equal in magnitude but opposite in direction, they are called balanced forces. So, they do not cause a change in motion. Okay. How about unbalanced? Okay. Forces that cause a change in the motion of an object okay, so we have here the sum of all forces acting on an object. So, net force is not 0. Okay, so that is all about the Module 1 forces. Now, so Sir Hector now will have a recap on Module 2, the laws of motion. Sir Hector?
Okay, so Ma'am Rio will start the recap on Module 2.
Yes, po. Ay, naririnig po ba ako?
Yes, Ma'am Rio.
Okay, so thank you Ma'am Lynn for having us short but may substance na recall sa ating it's all about forces and the types of force. Now, let's have the laws of motion. Okay. It's named before Sir Isaac Newton. Okay, so let's have first the law of inertia, which is the first law of motion. So this law states that an object at rest remains at rest at an object, and an object in motion will continue to move at constant velocity unless acted upon by a net force. So dito sa first law ni Newton, ang ibig lang sabihin niyan, simply, in simple words, ang object na hindi gumagalaw ay patuloy na hindi gagalaw unless may unbalanced force na mag-touch or ang tawag dito, yes, dito sa object na ito. And ang gumagalaw naman na object or anything will continue to move, it will continue to move unless acted upon by an external force. So mag-stop yun kung merong mag-act na external force or unbalanced force sa object na yon. So there are two conditions sa first law of motion ni Newton. So una dyan ay yung objects at rest at pangalawa ay ang objects in motion. So the first part of Newton's first law concerns sa mga object na hindi gumagalaw or yung mga objects at rest. So an object at rest, again, will remain at rest unless acted upon by an external force. So you are familiar, lahat tayo, di ba? Doon sa fact na nothing in nature will start by itself. Di ba? Parang, ano yun? Di ba? Kaya, it's a fact na hindi gagalaw ang isang object kung walang gagalaw dito. So, halimbawa dyan, yung a stalled car must be pushed to its, to start its motion. Diba? Yung halimbawa yung cellphone ko na nandito sa table ngayon, kailangang may pumulot dyan para gumalaw. Ganon din dun sa ball na hindi gumagalaw, a ball stays in place until you kick it, or any person or anything will move that ball. Ganon din yung mga puno sa paligid natin. These trees stay in place and carried by a force of water during floods. Or, ayun. Now, dun tayo sa pangalawa, which is objects in motion. So, a person, ayun, sabi dito, a person moves with the same, halimbawa, with the same velocity as the vehicle while inside it. So, halimbawa, nakasakay ako sa isang velocity, vehicle, yung velocity ng vehicle na yon ay ganun din ang velocity ko. So, when the brakes are suddenly applied, di ba? I will experience being thrown forward, di ba? Kasi nga, sabi kanina, an object in motion will continue to move unless acted upon by an external force. So, para pag suddenly na inapakan yung brake, mag-move forward ako doon sa vehicle. Now, the braking force changes the state of motion of the vehicle from motion, in motion dati yung vehicle, and then 2, rest. Kasi nga, inapakan yung brake. Now, but this force is not acting doon sa object, hindi siya nag-act sa akin, kundi doon sa vehicle. Hence, okay, kaya ako, I will continue to move forward, okay, with the same velocity until a force stops me. Okay, for example, kapag ako ay naka-buckle up or my seat belt, yung seat belt ko ay yes, yun, nakalagay sa aking, ayan. Okay, ayun. So, yun po, Sir Hector.
Okay, so yun po yung first law of motion by Sir Isaac Newton. So the second law of motion by Isaac Newton is what we call the law of acceleration, which states that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object. So kung mapapansin nyo, there are 2 concepts under this law. The first concept is all about the acceleration and the net force. According to this one, acceleration and net force must go in the same direction kasi directly proportional sila. Kung ang direction ng net force mo ay papunta sa kanan, ang acceleration ng object na in-applyan mo ng force ay papunta rin sa kanan. Ganun lang kasimple yun. Kapag yung force mo na in-apply mo ay papunta sa taas, yung object na naka-receive ng force mo na yan ay papunta rin sa taas. Yun yung first concept. And then the second concept, sabi dito, acceleration is inversely proportional to the object's mass. So dito naman, nakasalalay naman sa mass ng object kung mabilis ba yung acceleration ng object o mabagal ang acceleration ng object. So, ang halimbawa niyan, kapag nasiraan yung tricycle na walang laman at itutulak mo yun na mag-isa, kaya mo siyang itulak. Pero kung ang tricycle nasiraan at mayroong lamang 5 kaban ng palay, mahihirapan ka itong itulak. So kapag mas malaki yung mass, mas mabagal ang acceleration or mas mabagal ang kanyang galaw. Kapag naman mas magaan ang kanyang mass, mas mabilis ang kanyang acceleration. So ganun lang kasimple ang linalaman ng second law of motion ni Newton. That is the law of acceleration. Okay, Ma'am Rio?
Okay, thank you, Sir Hector. So, tapos na tayo sa law of inertia at saka law of acceleration. Ngayon, dito na tayo sa panghuli, which is the law of interaction. So, this law, the third law of motion states that for every action, there is always an equal and opposite reaction. So, I have your example. Ang example niyan, yung mga ibon na lumilipad, diba? So, these birds are flying gracefully through the air. Paano ba sila nakakalipad? So, itong mga ibon na to, nakadepende sa Newton's third law of motion. So, as the birds push down on the air with their wings, diba? Ngayon, ang opposite reaction niyan, the air pushes their wings up and gives them lift. Another example pa dyan, yung kung paano mag-work or yung pag, ang tawag dito, pag, yung rocket, okay? Yung pag, yes, yun. The hot gases push air, the inside tube of the rocket. That is why, ayan, the gases move downward, then the rocket moves in the opposite direction. Yan. So that is the third law of motion, which is the law of interaction. For every action, merong kabalikat yan na equal and opposite reaction. Yan. So, ayan po, ang ating simple, ayan, but meaning na ating recall ngayong araw. Ngayon, punta na tayo sa ating focus for today, which is all about potential energy and kinetic energy. So, napakinggan nyo kanina yung ating radio-based instruction. I hope our dear learners, nakinig kayo kanina. Sir Hector, ano ba
Yes,
ang ginawa mo kanina bago tayo mag-live o umere?
Ay, okay, ma'am. So, ang ginawa ko kanina bago tayo umeri, ma'am, syempre, inayos ko yung mga materials na gagamitin natin. Inayos ko yung laptop, yung mesa, at saka konting naglinis na rin ako dito sa working area natin ngayon. So, ikaw naman, Ma'am Linda, ano naman yung ginawa mo kaninang umaga?
Okay. So, ginawa ko kanina, syempre, pagkagising ko, nag-prepare ng breakfast, naglinis ng bahay, and then naligo na ako, and then nakicommunicate na ako sa aking mga estudyante. So, sinabihan ko na sila na makinig ngayon sa ating RBI. Okay. Ikaw naman, Ma'am Rio, ano ba pinagkakabalahan mo ngayon?
Okay, ganun din po, Ma'am Lynn. So, kaninang pagkagising ko, syempre nag-breakfast na ako, naligo, and then nagkumustahan time kami ng aking 8 Ivory. Hello, 8 Ivory! And then, ayun, nag-send ng mga modules na yung ina-expect na matapos this week. Ayan. Ngayon, etong mga gawaing bahay o ano pa man, alam nyo ba, our dear learners, na magagawa natin ang mga ganitong mga bagay dahil syempre meron tayong energy, tinatawag na energy. Diba, Sir Hector?
Oo, energy, ma'am, ang nabanggit mo, di ba? Ma'am Lynn,
Yes.
ano nga bang ibig sabihin ng energy?
Okay. So, pag sinabi nating energy, so scientifically speaking, energy is the capacity to do work. And energy can be categorized as potential energy and kinetic energy. So, Ma'am Rio, so what is potential energy?
Okay, thank you, Ma'am Lynn. Ang potential energy, okay, potential. It's the stored energy of an object, which is not, dear learners, hindi gumagalaw. Ayan, example ng mga potential energy. Kindly comment down kung ano tong mga bagay na may stored energy na hindi gumagalaw. Tignan nga natin kung alam nyo ang mga sitwasyon or mga bagay na hindi gumagalaw. Mag-comment nga kayo, our dear learners. Okay, so ang potential examples of potential energy, ito yung mga, itong libro ko dito ngayon na naka-place on top of the table. May potential energy yan. Diba, Sir Hector?
Ibig bang
Yung
sabihin,
mga-
ma'am, maski hindi gumagalaw, mayroon pa rin siyang energy?
Yes, Sir Hector.
And that energy is what we call potential energy. Tama ba, ma'am?
Yes, Sir Hector.
Yes, Sir Hector.
Ay, sige po.
Okay, so Ma'am
Okay,
Rio,
potential simply means, okay, the energy has the ability to do something useful later on. Okay?
so Ma'am Rio, paano ba natin mako-compute or how can we calculate the potential energy?
Yes, so we have here the formula in getting the potential energy of an object. So PE is equal to mgh. Itong M dito, our dear learners, is the mass of the object. Ang G ay acceleration due to gravity. na may constant value na 9.8 meter per second square. So itong gravitational acceleration due to gravity na to, na constant na to, ay dito lang sa Earth. Okay? So iba ang acceleration due to gravity sa ibang mga planeta. And the last one is the h, which is the height of the object. Now, ano naman ang let's have some example, Sir Hector.
Yes, ma'am. Para may lalo nating maintindihan kung ano nga ba yung equation na pinakita sa ating kanina ng PE, we have some example para sa simple computation. Ma'am Linda, pakibasa nga ang ating sample.
Okay, sir. Okay, so here's the sample problem in potential energy. Mark has an object suspended in the air. It has a mass of 30 kilograms and is 40 meters above the ground. Calculate the object's potential energy.
Ma'am Rio, ano muna nating i-determine? Ano muna ang dapat natin malaman, Ma'am Rio?
Okay, so wag kakalimutan yung mga bagay na dapat munang alamin bago natin ma-solve ang problem or word problem. Let us first know the given in the problem. Ano ba yung mga given? So, una dyan yung height, which is 40 meters. We can identify the given by looking at the units. Diba? So, itong meter is for height. The acceleration due to gravity is 9.8 meter per second squared. And the mass, diba? The unit for mass is grams, kilograms, but the given here is 30 kilogram. And the unknown, which is what is asked, diba? Ang sabi dyan, calculate the object's potential energy.
Ma'am Rio, mayroon lang akong napansin dito sa given natin. Doon sa problem natin, Ma'am Rio, wala namang value yung acceleration due to gravity. Pero pagdating doon sa given, bakit mayroon na? Saan mo ba kinuha yun, Ma'am Rio, yung value ng gravity?
Yes, Sir Hector. Okay, sabi natin kanina, ang acceleration due to gravity ay may constant value na 9.8 meter per second squared. So, always na present yan or constant kasi yan, constant value, Sir Hector.
At sa kakaragdagan, Ma'am Rio, lahat kasi ng object ay hinihila ng pull of gravity. Di ba, Ma'am Rio?
Yes, Sir Hector.
Yan, kaya constant. So, pagkatapos natin ma-determine ang mga given values at saka kung ano yung ating i-calculate, let us now proceed with the solution. So, using the formula given earlier na kung saan ang PE stands for potential energy is equal to mgh. Okay? So, meron tayong values ngayon na isa-substitute. For mass, we have 30 kilograms. Sa acceleration due to gravity, we have 9.8 meter per second square. And then dun sa kanyang height ay 40 meters. Just simply get the product. Pag sinabi natin get the product, imumultiply lahat natin ang mga numbers na yan. And the product is 11,760 kilogram meter squared per second squared, or simply 11,760 joule. Okay. So, yung joule, that is in honor of James Prescott Joule, who made a significant study on energy. So, bilang parangal, ipinasunod sa kanya yung unit, the SI unit for energy. Kung mapapansin nyo, meron tayo dito dalawang units for energy. Yung isang mahaba, that is the expandable unit for joule, yung kilogram meter square per second square. Meron pa tayo dyan isa pang unit for joule, na kung saan ito ay Newton meter. So kapag na-encounter nyo yung mga units na yon, iisa lang ang tinutukoy nun. Yun ay unit ng energy. So ulitin ko yung mga units ng energy na maaari nyong ma-encounter. Una, yung joule or yung big letter J. Pangalawa, yung kilogram meter square per second square. And then yung pangatlo, ito yung Newton meter. So inuulit ko, lahat ng mga units na yon ay unit ng energy. Okay. Ma'am Rio? So kay Ma'am Linda tayo. Ma'am Linda, what are the factors affecting potential energy?
Okay, so may mga factors na nakakaapekto sa potential energy. So the factors affecting were the mass of the object, acceleration due to gravity, and the height of the object. Okay, so Ma'am Rio, okay, what happens to the potential energy of an object if the mass is tripled and the height is constant?
Ano ulit, Ma'am Lynn? Kindly
Okay.
repeat
So,
your
di ba?
question.
Okay. So, nabanggit ko yung mga factors affecting the potential energy, di ba? Okay, so you have there the mass of the
Yes.
object, acceleration due to gravity, and the height of the object, no? On a certain reference point.
Opo.
Ngayon, what happens to the potential energy of an object if the mass is tripled and the height is constant?
Okay,
Constant ng
syempre, kung na-triple yung ating mass, tama ba? Yung mass or yung
Yes.
height?
Mass.
Yes, yung mass, syempre, ang mangyayari dyan dahil ang PE ay directly proportional sa ating mass and height, it will also be tripled.
Okay.
Ayaw.
Tama ba, Sir Hector?
Tama, ma'am. Ganon din sa height, ma'am. Kapag nadoble ang height, doble din ang i-increase, no? Madodoble din yung potential energy from its original value.
Yes.
Yun po ang ibig sabihin ng PE is directly proportional. Sa kabilang banda naman, ma'am, kapag ang mass ay bumaba, bababa din ang kanyang potential energy. Ganon din po sa kanyang height, yung height na kinalalagyan ng isang object. Ma'am Rio?
Okay. So, let's have example, Sir Hector, para mapatunayan na kung dinoble mo yung mass ng isang object, ay madodoble din yung kanyang potential energy. So, for example, ang mass natin ay 2 kilograms. Constant ang value ng acceleration due to gravity at given na height ay 2 meters. Now, getting the product of this 2 kilogram times 9.8 times 2 is equal to 39.2 joules. Ngayon, doblehin natin yung mass from 2 kilograms, gawin nating 4 kilograms. So, 4 kilograms times 9.8 meter per second squared times 2 meters, okay? Ang tawag dito, niretain natin yung value ng height. Ang product ay magiging 78.4, which is doble sa 39.2 na dating potential energy niya.
Okay, so ganun ang magiging resulta, Ma'am Rio.
Okay, so siguro maliwanag na sa learners natin ang potential energy, no, Sir Hector and Ma'am Rio.
Oo.
Yes.
Ang nandun kasi sa ating learning competency, we will identify the factors affecting potential energy at saka kinetic energy. So, by that question, kanina, na-raise ni Ma'am Linda, nasagot na natin yung factors na nakaka-apekto sa potential energy. Ito nga yung mass, acceleration due to gravity, at saka yung height ng object. Dito sa tatlo na to, ang mas nakaka-apekto doon sa potential energy ay yung kanyang height. Okay. Ganyan. Ganon din yung kanyang mass. Ganon din. Nakaka-apekto din siya. The next, Ma'am Rio, sa kinetic energy naman.
Okay. So, ayan. So, kinetic energy, kung kanina ang potential energy, ito yung stored energy ng mga object which is not moving. Ang kinetic energy naman is the energy that object possesses due to its motion. Diba, Sir Hector? Examples dyan ay yung mga gumagalaw na mga object like bouncing ball, mga flying airplane, yung mga naglalakad na ang tawag dito, mga tao, 'di ba? They have this kinetic energy. And we could compute Sir Hector?
At para ma-compute natin ang kinetic energy ng isang gumagalaw na bagay, meron din tayong formula na dapat sundin. Ito nga yung KE, which is equal to 1/2 mv squared. So dito sa presentation natin, hindi ko lang nailagay na squared yan. Okay. So dito yung m, that is the mass of the object. Mv, that is the velocity of the object. In other references, instead of using velocity, they use speed. So what is the difference between speed and velocity? Kasi baka naman sabihin nyo later on kapag naka-encounter kayo na speed ang ginamit, baka sabihin nyo nagsisinungaling ako. So the only difference is that in velocity, the direction is given. But in speed, walang indication ng direction. So kung mapapansin nyo dito, velocity ang ginagamit natin dito to indicate a certain direction. Pero inuulit ko, pwede rin lang ma-encounter nyo ay speed lang. Kapag speed lang, hindi kinoconsider doon ang direction. So, para mas lalo natin maiintindihan kung paano ang pag-compute ng kinetic energy ng isang moving object, we will take a sample problem. Ma'am Linda, pakibasa nga yung natin, sample problem.
Okay, so here's the sample problem in kinetic energy. Ray serves a ping pong ball with a velocity of 30 meters per second. If the ball has a mass of 0.15 kilograms, what is the kinetic energy or the kinetic energy of the ball? So that's the problem, sir.
Next step, Ma'am Rio, ano nang gagawin natin? We have already the problem.
To identify the given, Sir Hector. So the given there, mass, okay, 0.15 kilogram, velocity 30 meter per second, and syempre, ano pang hahanapin natin?
Okay, yung hahanapin natin is the kinetic energy of the ball. So after knowing the given, let us now proceed with the solution. So take note yung ating formula for KE. Ang gagawin lang natin, isa-substitute lang natin itong mga nakuha nating mga values. Okay. Ito, sinubstitute na natin. Ayan. So we have 0.5 times 0.15 times 900 meter square per second square. Ma'am Rio, saan nakuha yung 900? Wala naman tayong 900 kanina dyan.
Okay.
Ito, 900 meters. Sige, ma'am.
Okay, ang value kasi ng velocity natin dyan ay 30. And 30 squared is equal to
Ano ma'am? 30 squared is equal to
900.
Yes.
900. Kasi ang magiging lawas niyan, 30
times 30, sir, di ba?
Oo.
Yes.
900. Ma'am Lynn, bakit may 0.5 dito? Wala naman tayong 0.5 dito sa given. 1/2 naman ang meron.
Saan?
Dito ma'am sa kinetic energy, ang equation kasi natin dito ma'am, KE is equal to 1/2 mv squared. Pero nung nag-substitute tayo ma'am ng mga values, may lumitaw na 0.5. Saan nanggaling yun ma'am? 0.15, yun yung mass. Tama po ba ma'am? At saka yung 900, yun yung 30 times 30, yun yung velocity squared niya. Ang tanong ko ma'am, saan nanggaling ang 0.5 ma'am Lynn?
Ay, di ba may 1/2 kasi tayo dyan, Sir Hector? Dyan sa formula natin.
Oo ma'am.
I-convert lang natin to decimal.
Oo, for easy computation. Kasi kung
fraction kasi
multiply
yan.
tayo, fraction kasi yan, mahihirapan tayo, even the students.
Okay, yes.
For easy computation, kinonvert lang natin siya sa decimal point. Kaya meron tayo 0.5. Kung mapapansin nyo, wala siyang unit, ma'am, di ba?
Oo.
Wala siyang unit. Ayan yun ang dahilan. So ngayon, mas madali na natin kunin ang product ng mga given natin, yung mga values natin. So ang magiging sagot ay 67.50 kilogram meter squared per second squared, or simply 67.50 joules. Okay. Ano ulit yung isa pang unit ma'am ng joules na hindi nakasali dito?
Newton meter.
Yes, that is the Newton meter. Yun pa yung isang unit ng energy. Okay. So, Ma'am Lynn, what are the factors affecting kinetic energy?
Okay. So, if potential energy ay may mga factors also affecting the potential energy, ganyan din sa kinetic energy. So, the factors affecting kinetic energy are, one is the mass of the object and the velocity of the object. So, mass and velocity, sir.
Okay, mass and velocity.
Yes. Sir, may tanong nga ako sige, magtanong nga ako.
Sige, ma'am.
Sabi kasi dyan, kinetic energy is directly proportional to its mass and velocity. Okay? Now, what will happen when velocity is doubled? The mass is the same. Ano ba mangyayari sa velocity natin kapag na-doble ito? But the mass retains siya. The same.
Sino ang tinatanong mo? Sino ang gusto mong sumagot dyan, ma'am?
Pwede, si Ma'am Rio. Ma'am Rio?
Yes, okay. Yes. So ma'am, the kinetic energy increases 4 times its original value. So for example, ang kinetic energy na nakuha natin kanina ay 1, diba? 1 joules. Magiging, kapag dinoble mo yung velocity, ang magiging value ng kinetic energy ay 4 joules. Yan ay dahil sa exponent na 2 sa velocity. Ngayon, kapag ang velocity ay mahati, or magdi-decrease ang kinetic energy. Hello? Ayan. Kapag naman ang velocity ay mahati, okay, magdi-decrease ang value ng kinetic energy ng 4 na beses din, 4 times sa kanyang original value. Now, if mass, paano naman kung yung mass ay nadoble? Yung kinetic energy din.
Ma'am Rio, kapag ang
yes,
mas
Sir
naman
Hector?
Kapag mas naman ang nadoble at constant yung kanyang velocity, madodoble din ang kanyang kinetic energy, ma'am. Okay. Kapag naman yung kanyang mass ay nag-decrease ng double, magdi-decrease din ng doble yung kinetic energy niya. So hindi kagaya kanina doon sa velocity na kung na-doble siya 4 times na mag-i-increase yung kanyang kinetic energy. Pero dito sa mass, kung doble yung increase niya, doble lang din yung increase sa kanyang kinetic energy.
So,
Nakuha
Sir
ba, Ma'am
Hector?
Rio? Yes, ma'am.
Okay, yes. Opo, tama po. Now, ano nga ba bakit natin pinag-uusapan ngayon ang potential energy and kinetic energy? Do they have relationship? Ano ba ang relationship between them? Sir Hector.
Okay. Base, ma'am, doon sa ating pag-aaral, the relationship that exists between potential energy and kinetic energy is inversely proportional. Pag sinabi nating inversely proportional, when one quantity is increasing, the other quantity is decreasing. Para bang yung seesaw sa
Kasi nga
plaza
inversely,
yan,
di ba, Sir Hector?
Oo, yun yung ibig sabihin nun. Di ba, ma'am, sa seesaw, kapag hindi naman kayo pwedeng sabay na tumaas na dalawa at sabay kayong bumabang dalawa kapag nakasakay kayo sa seesaw, ma'am. Di ba? Okay.
Yes.
Yung kung
Kailangan
mas
yung
mabigat,
isa asay taas. Kung mas mabigat ka, ikaw ang asay baba. Yung mas magaan
Yes,
ang asay
ma'am.
taas.
Oo. Ganon yung relationship na nag-e-exist sa PE or potential energy at saka sa kinetic energy. Ngayon, para lalo natin maiintindihan pa yan, meron tayo dito yung illustration showing the relationship between PE and KE. Nakikita nyo ba, ma'am, yung picture, yung illustration?
Yes, Sir Hector.
Yes, sir.
Kitang-kita.
Okay. So meron tayo dyan yung isang character, ang tawag sa kanya ay ski jumper. Okay. Siya yung nag-i-slide sa snow. Ayan, pag familiar kayo sa sport na yun. Yung may suot-suot sila sa kanilang paa na mahabang parang kahoy. Okay, ski jumper ang tawag doon. Ma'am Lynn, gaano kataas yung ski jumper buhat doon sa ground?
Okay. So, gaano kataas? So, diyan sa illustration is 100 meters, sir. Yan.
Okay, ano ang kanyang potential energy at saka kinetic energy diyan sa kinalalagyan niya, ma'am?
Okay. Sa point A, ang kanyang potential energy is 50,000 joules. At ang kinetic energy is 0 joules. Yan. Okay. Ma'am Rio, ikaw nga naman, ano naman ang potential energy at kinetic energy ng ski jumper naman sa point B? Tingnan ko nga kung matalas din yung mata mo. Kikita mo?
Ayan, Ma'am Lynn, dyan sa point B, ang potential energy na meron dyan sa ski jumper na yan ay 30,000 joules at ang kanyang kinetic energy naman ay 20,000 joules. Okay, moving on, Sir Hector. Sa point C at point E, okay, C to point E, ano ang kanyang PE at KE?
Okay, doon sa point C, ang kinetic energy ng ski jumper ay 35,000 joules, habang ang kanyang potential energy ay 15,000 joules. At doon naman sa point E, ang kanyang kinetic energy ay 50,000 joules at ang kanyang potential energy ay 0 joules. Ma'am Linda, may napapansin ka ba sa mga numbers na meron dyan?
Okay. So, ang napapansin ko dyan sa potential and kinetic energy natin, the relation between the two, as the potential energy decreases, the kinetic energy increases. So, the amount lost in potential energy is the amount gain of kinetic energy and vice versa, sir.
Ma'am Linda, meron ba tayong nasayang na energy buhat doon sa potential energy papunta sa kinetic energy?
Wala, sir. Walang nasasayang. Kasi kung maalala ko doon sa ating law of conservation of mass, Ang sabi doon, energy
Of
Law of
cannot be
conservation of
created.
energy.
Law of conservation of energy, yes. Energy cannot be created or destroyed. It can only be stored or transferred. Tama ba ako, sir?
Yes.
Okay, ma'am. Kung mapapansin nyo, yung mga values na nandito, kagaya ng ski jumper sa point B, yung kinetic energy niya ay naging 20,000 joules. At ang kanyang potential energy ay 30,000 joules. Pero kapag ito total natin, yung lahat ng energies, yung PE at saka KE, still ang total ay 50,000 joules.
50,000.
So,
Yes.
oo.
So patunay lang yan,
Any
Sir
point kahit-
Hector, na walang nasayang na mga energy. Na-convert lang siya from PE to KE. Tama ba?
Oo, ganun yun. Tama,
Or
na-convert
PE to
lang
KE.
siya. Kasi yan yung linalaman ng law of conservation of energy.
Energy.
Oo. Ma'am, maliban dyan, meron pa tayong ipapakita na ito naman ay isang animation na kung saan, okay, saan dito? Ito, yung roller coaster. Hintay lang natin. Dito natin malalaman o mas lalong maiintindihan yung law of conservation of energy or yung transformation ng kinetic energy to potential energy. So meron tayo dito isang RAM. Yan. Meron tayo dito legend, etong me, ako yon, yung nakasakay doon sa cart na yellow, ay na orange. And then yung KE, that is the kinetic energy of the cart. Okay? And then PE, yan yung kinetic, potential energy ng cart. So ang initial point natin dun sa taas, wherein ang kanyang potential energy is at its maximum, so 100%. Ang kanyang kinetic energy ay 0. So, let's start. Okay, play natin. So, ano nangyayari sa potential energy at saka sa kinetic energy?
Tumataas yung kinetic, bumababa yung potential, tataas yung potential, bababa ang kinetic.
Okay. Pero
Inversely.
yung total na energy na mayroon, ma'am, nag-iiba ba? Yung me doon na violet, nag-iiba ba
Hindi.
ang value?
Hindi, constant lang siya.
Constant. Oo.
Okay, constant. So nagbabago lang dyan. Ngayon, iibahan naman natin, ma'am, yung position. Okay, sige, ito, ilagay natin doon. Yan. Ibababa natin. Yan, tingnan natin kung anong mangyayari. Then, i-play natin, start ulit natin. Anong mangyayari?
Bumababa naman yung kulay violet, sir, yung me.
Bakit kaya bumababa, ma'am? Ano ba nangyayari doon sa kwan?
Anong nangyayari na dyan? Ba't bumababa?
Asan ba yung starting location ng kanina nito, ma'am? Ano kaya mangyayari kapag nag-stop na siya dito sa baba? Okay. Ayan. Ulitin natin, ma'am. Okay. Ulitin natin. Supposed to be doon is etong potential energy, itong me, hindi dapat nagbabago yan, di ba, ma'am? Nagbabago dyan.
Okay, Sir Hector.
Ma'am?
Siguro, sir, bas ano pa, yung pinapakita natin yan, i-forward natin sa mga GC ng ating mga estudyante at i-will discuss pa uli natin during our usap tayo. Diba, Ma'am Ria, Sir Hector?
Yes.
Okay. So, learners, ipopost namin yan sa mga GC natin at magkakaroon tayo ng mga conduct usap with your science teacher. And also, meron kaming ibibigay na performance task, doon na lang din namin sa GC ibibigay. Kaya dapat maging active tayo lahat sa ating GC. So, thank you very much mga dear learners, especially the grade 8 at sa lahat ng mga nanonood ngayong hapon.
Okay,
Okay,
so
thank you,
bilang
Sir
pangwakas, Ma'am Rio.
Ayan, maraming salamat pong muli sa inyo pong pakikinig sa aming programa, Scientific Time. Okay. Sir Hector, may sasabihin ka pa po?
Oo, so ang tabayanan ng ating mga learners yung susunod na episode natin dito sa Scientific Time. So kung nag-enjoy kayo dito sa ating live streaming ngayon, I hope na mag-i-enjoy pa rin kayo sa mga susunod naming mga live streaming. Ma'am Rio?
Okay. So ayan, so muli po kaming nagpapasalamat sa inyo sa muling pakikinig at ayan, pagantabay sa programa ng Science Learning
Area.
Muli po, maraming salamat! Muli
Thank you, Sir
sa pakikinig.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is Science. And now, here is your host for the day. Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kaalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR FM.
Nais mong matuto, buksan mo ang iyong radyo. Lahat kami ay narito, tapat sa aming serbisyo. Walang problemang di malalampasan. Magliliwanag ang ating kinabukasan. Dance Radio, silid-aralan sa radyo. Hatid namin makabagong paraan ng pagtuturo. Kahit saan at kahit kailan, hindi ka iiwanan. Hatid namin bagong kaalaman. Edukasyo'y susulong, basta't magtulong-tulong. Sulong edukalidad, Dance Radio. Learning is the name.